We start with the webinar. Please ensure that you mute yourself, you do not share your screen, do not record the webinar, and please put any questions that you have in the chat. Now let's begin with a brief introduction about Sears. Now we are a niche cloud engineering business that was born in the cloud. In fact, we have been a technology-led business transformation company for the last 16 years. Driven by the idea of driving technology-led digital transformation, we are now one of the top cloud and analytics solution and engineering companies in the Asia Pacific, Europe, and the United States. We work with organizations across multiple geographies and specialize in infrastructure and application partner for the last 10 years. We are a premier partner with Google Cloud, and we work very closely with them on a number of various projects and customer engagements. Next slide, please. As aforementioned, we have a footprint in 14 locations across the globe with over 3,000 customers, over 300 engineers, having over 150 professional and associate Google Cloud certifications. We cover all of the major verticals and provide highly tailored solutions based on the client's use case or problem area. Next slide. The hosts for this afternoon are Chandni Sharma from Google and Manan from Sears. Chandni is a customer engineer with Google Cloud, and in this role, she specializes on big data and AI customer use cases, along with leading an internal team at Google related to data insights. Previous to Google, she has worked as a senior big data science professional and describes herself as a very data-driven person. Manan from Sears is a data engineer and has been with Sears for the last 3 years and working on an experience with data warehousing solutions, specifically on Google Cloud. Manan is a certified professional data engineer in Google Cloud and has consulted various customers with their data modernization needs. Next slide, please. So this is the agenda for today's webinar. We will start off with a brief about why data is important in today's time and age. Then we'll move on to Google's data products and discuss BigQuery in detail. After that, we'll be covering a case study on data modernization that Sears has delivered. Manan will then give us a guided lab demo on real-time data sync from my question and answer session and wrap up the webinar. So I'll hand over things to you, Chandni, and we can begin.
I would go forward with explaining exactly why data modernization is important in the first place. So to begin with, most companies are either becoming digital or maybe starting from scratch, right? And when they are making these transitions, they're not just looking at how they can move from their existing computing to the cloud to reduce costs, increase reliability and security, but they're also looking to create new opportunities. So cloud can help you do both. It can meet your existing needs, at the same time, help you invent your future. So one of the ways that these customers are creating opportunities is like through reimagining their business based on cloud computing. Some of the CEOs, or I would say maybe board level executives, they think about the questions like, how do we engage with customers better? How do we run businesses on better insights? How do we partner better? How do we make our employees more productive? In fact, in some cases, how do we rethink our business model? Next slide, please. Yeah, with that, personalization often helps. As I can say, surely many of you find it very convenient to shop or sell online when you get recommendations for etc. And whenever there's personalization at scale, it demands things like recursive learning, customer reviews. And these must be leveraged across channels, products, and services. Some of the examples mentioned here are for like home automation, financial health, and even something like personalized medicine. Next slide, please. Another thing that customers also want to do is hyper-optimize their business. Why do I say they want to optimize? Because optimization is also very important, key to enhance your business. Like we can't continue to use legacy methods with the evolving technical needs. We have to use the power of data or AI, whether in marketing, supply chain, or even like something as simple as customer support. Next slide. So to summarize why people would need data modernization solutions and what value it actually brings, we can actually classify it into 3 parts. Number 1 is how you can, move and improve your data warehouse infrastructure at a very, I would say, lower level, meaning maybe reducing your TCO. And the next upper half would be building new capabilities. As I explained, it will obviously maximize your revenue and lower risk. And at the topmost level, you're making a transformational impact. Right now, when you hear things about like AI, ML, APIs, so many collaboration tools, you're rethinking your business. And this is how you can maybe summarize the whole value that these solutions bring. Next slide, please. And for folks who are highly technical and are maybe like architects, developers, and software engineers, if you want to view and imagine it end to end, how it would look like, this is a good picture. So it starts from extreme left side where you have like various kind of data sources. You want to ingest that data, maybe it's streaming or maybe it's batch process, and you want to understand what it really talks about. And based on those insights, you want to maybe make some recommendations using tools like Google machine learning tools that I mentioned here, and build like applications or just some engines. So this is how it's fully supported by our AI-ready data solutions. Next slide, please. Now, when you think about it, Google has been innovating around data and analytics since our founding. Back then, the only way that we had to share about innovation was in the form of research papers. Next slide, please. This is a good slide to just imagine the whole journey from the beginning. So we have published a number of groundbreaking papers on technologies like MapReduce and Bigtable, and this really got people excited. Like they even implemented open source projects, including well-known projects as Hadoop, HBase. But there was inevitably a lag from the time we first created the systems to when we published the papers. So that was a situation which could have made things more useful to the outside world. Next slide, please. And hence Google Cloud Platform. So with Google Cloud Platform, we now have the ability to share not just papers that describe our data tools, but the actual tools themselves. So this is coming directly from Google. That means you get access to more advanced technologies even faster. Whether you think about something as BigQuery, whether you think about something as data flow, or even something as PubSub machine learning engine. Next slide, please. One of the key products I feel, and I'm sure a lot of people would agree with me who know the whole stack of big data products on Google Cloud, and many say that this is their favorite, is Google Cloud BigQuery. So what is Google Cloud BigQuery? It's like our enterprise-ready data warehouse solution for analytics. It's like gigabyte to petabyte scale storage solution where you can do SQL queries. There is like a lot of encryption, durability, high availability. It's also fully managed and serverless. At the same time, there are some very, very unique features like you can build in ML insights on top of the BigQuery, which recently has been announced a couple of years back, named as BQML. At the same time, there's high-speed, in-memory BI engine for faster reporting analysis. And also there are a lot of integrations, like whether you talk about sheets or GIS data, for example. Next slide. So far we talked about what BigQuery does, but how does it help in a business way? This is how I would explain it. Like in a very traditional data warehouse environment, you'll have to do a lot of things like focus on monitoring, you have to focus on deployments, then resource provisioning, and so many things. And when there are a lot of things involved, obviously you're spending a lot of time and resources. But with a solution like BigQuery, you're actually eliminating the need of so many system engineering and from the data analytics workflow. At the same time, you can actually focus on just bringing the main value to your business, which can come from data analysis. Next slide. These are just some dashboards that you can imagine you're building, maybe leveraging BigQuery or any of the other products. Next slide, please. And of course, you also get a lot of integration. So whether you're using systems like Talent, Informatica, you're using something as Looker, you're using, I'm sure a lot of data science folks, they use R, they use Pandas. So all that is easily integrable with BigQuery. So it makes really a good product where you can not just build something from scratch, but also leverage what you have already been building. Next slide, please. And when we're talking about all the capabilities that you get, something to also mention is what is that you get for free and what really saves a lot of IC researchers' time. One of them is definitely the public data sets that we offer through BigQuery. Now, BigQuery hosts for you a lot of public data sets that you can, get access and integrate with your applications. So what happens is that Google will pay for the storage of these data sets, but will provide you public access to these data sets via Google Cloud, Platform project. So you will be paying only for the queries that you perform on the data, and also you will be getting the first terabyte full of query processing per month free. So that's exciting, right? Next slide, please. Now, as we have talked so far, you really want to spend time in the data, but instead what happens generally is that you end up spending a lot of time in operations, database, and so many things. So if you have to imagine it in a much simpler form, this is like a good picture that you can think about it as. So BigQuery really at the center hub. And at the left side, you have so many integrations where people might want to drive insights from. At the same time, once you have pulled in the data into a BigQuery table, for example, you want to extract some insights from that, do some cleaning using maybe product like a data prep, and then you do some ETL transformations, maybe using a product like data flow. And then you want to visualize into a BI tool, something like as Data Studio. Like as I mentioned in previous slides, there are a lot of other products that are integrable with BigQuery, but this is just a general flow where BigQuery is really the center hub and helps you with all of these use cases. Next slide, please. And this is an end-to-end, I would say, very general architecture where it just not talks about the integrations, but mainly talks about the processes that you can do with BigQuery. So whether it's like some streamline processing or batch processing, you can do that. And with that, I would let Manan come in, and he would be covering a case study that Sears actually worked on this. Thank you.
Yes, Manan.
Okay. Thank you.
Yes, ma'am. You are audible.
So thanks, Stanley, for a comprehensive introduction of GCP and BigQuery. So now we'll discuss about how Sears built a data lake for one of its customers and leverage BigQuery to make analytics faster for them and easier. So starting with the introduction, our customer was one of the largest B2B e-commerce platform in the Asian market and serving the sales and distribution of consumer products from fast-moving consumer goods, that is FMCG brands, FMCG to brands to retailers across the region. So their main application is designed to provide an end-to-end wholesale shopping experience for retailers by directly connecting them with the FMCG brand owners without the need of a physical intermediary or store. So as of today, the platform is enabling brand owners to reach over 70,000 retail outlets. So talking about some of the business challenges the customer faced prior to the project, the client wanted to provide more value to the customers on its platform by offering them insights gathered from sales patterns and consumption trends to uncover potential sales opportunities. Although their existing applications made the process of ordering, receiving inventory, and managing payments convenient, its existing data infrastructure could not cope up with the growing demands and the fast-paced nature of the business. Moreover, the client needed to manually perform extract, transform, and load, that is the ETL, on its data for reporting and analytics. As a result of this, reports would take up to 3 days to prepare, delaying insights and critical business decisions. Talking about the existing environment, it involved multiple MySQL tables hosted on Google Cloud SQL, along with existing SAP infrastructure. However, the legacy SAP systems had limitations in that it did not support change data capture capabilities because of the older SQL Server Standard Edition in the backend. So which made the overall data collection, processing, and extraction slow and inefficient. The end goals were to able to generate reports faster, which will be fresh up to the previous hour. So, starting with the first thing that we did, for the MySQL tables hosted on Google Cloud SQL, we deployed an open source change data capture tool called Debezium. So let me first start with the definition of Kafka Connect here. So Kafka Connect is an open source component of Apache Kafka, and it's a framework for connecting Kafka with the external systems such as databases, key value stores, search indexes, and file systems. So Debezium is built on top of Apache Kafka, Kafka Connect, and provides the Kafka Connect compatible connectors that monitor specific database management systems. It records all the row level changes within each database table in a change event stream, and applications simply read these streams to see the change events in the same order in which they occurred, and then the applications can respond to that stream. It has connectors available for several popular databases like MySQL, PostgreSQL, SQL Server, etc. For our use case, we deployed the Debezium's MySQL connector, which essentially taps into the binary log of the MySQL server to capture the changes in the table schemas as well as the data within the tables. So the connector captures the change events for row level inserts, updates, and delete operations, and then pushes them into a Kafka topic. The client applications, like the Kafka sync connectors, read those Kafka topics and pushes to respective locations. So we used the Kafka sync connector for pushing events from Kafka to Google Cloud Storage as it's visible in the image. Several applications can leverage the data that is coming into the Apache Kafka topic, and it can be used to update the values in your cache or the search engine reliably. So this is how the overall architecture looked like. Starting from the top left, one of the sources, as I mentioned earlier, was SQL Server Standard Edition, and it was external to Google Cloud. Due to the older version, it didn't support the change data capture out of the box. So we had to deploy query-based CDC mechanism instead of a log-based using batch jobs and Cloud Data Flow. The hourly batch data flow jobs were orchestrated by Apache Airflow. coming at the bottom left. For the MySQL tables, we already discussed at a high level about how we leverage Debezium and Apache Kafka to stream events to Google Cloud Storage in near real time. For each table, the data that is coming in cloud storage is partitioned based on a column which denoted the latest modified time or the latest updated time. For example, the rows which were updated in the last hour would go to its corresponding hour's partition in the Google Cloud Storage. Once the data was coming to Google Cloud Storage, the next step was to read only the relevant data needed for analytics, transform it according to the data model in BigQuery, and build and update the fact tables and the data mart tables in BigQuery, using which the reports will be served in Power BI. This downstream processing in the BigQuery was orchestrated by Apache Airflow. The data lake architecture that we built here also helped in fulfilling the machine learning use cases for the client. Going further, we will discuss a little more about Debezium. On the right-hand side is a sample snapshot of event data captured by the MySQL connector. Debezium and Kafka Connect are actually designed around the continuous stream of event messages. However, the structure of these events may change over time, which can be difficult for the consumers to handle. To address this, each event contains the schema of the table and hence the schema of the content of the message as well. This makes each event self-contained. The payload field contains the information that the change specifies the state of the row before and after the event occurred. The OP field denotes whether the event was a create, update, or a delete. And when the OP field is C for create, as it is in this example, the before field is null, since this change event is for the new content. Since Debezium connector works on the Kafka Connect framework, it uses Kafka Connect's JSON converter to serialize the record keys and values in the JSON documents. Alternatively, we can serialize the record keys and values by using Apache Avro, which is much more compact and efficient. For the historical load, when the Debezium MySQL connector is first started, it performs an initial consistent snapshot of your database. For the initial snapshot, it scans the database tables and generates create events on the decide the maximum number of rows that will be read in one go from each table while taking a snapshot. The connector will read the table contents in multiple batches of this size. And after taking the initial snapshot, it switches to reading bin log after the snapshot is completed. For setting up the monitoring of the MySQL connector, a lot of useful metrics are already available in the Debezium. We just need to consume and expose it to the Prometheus. But unfortunately, we didn't find any Grafana dashboards to visualize the Debezium metrics. So our engineering team at Sears built a dashboard and shared it with the Debezium community. The link for the blog and the open source dashboard is present on your screen. So now we'll talk about further downstream processing that took place after the raw data starts appearing in Google Cloud Storage. The raw data in cloud storage is partitioned according to a timestamp column from the table and has prefixes for year, month, day, and hour for each object. We created external tables in BigQuery, which leverages this already existing partitioning structure in cloud storage. An external table in BigQuery just points to a cloud storage URI and does not hold any data in BigQuery storage. For each table, we did one-time process of loading historical data, cleaning it, deduplicating it, and storing the results into a BigQuery native table, which actually, a native table actually holds the data in the BigQuery storage and is compressed and partitioned and for the optimal usage. In the diagram, it is denoted by deduplicated table 1 and deduplicated table 2. So every hour, the orchestration job will issue a statement like select column 1, column 2 from external table where hour is equal to previous hour, and it will go to that particular partition for that hour in the GCS, and it will scan only the necessary partitions, and the resultant rows of this query will go into a delta table which is shown in the image. These delta rows will be cleaned and merged with the deduplicated main table. After this process is finished for all the participating tables, the reporting queries will update the fact and the data mart tables with the fresh rows, and consequently the reports in the Power BI will reflect the updated metrics. The fact tables were also partitioned on a timestamp column, so that when you open a report, let's say for current month, it will only scan the necessary partitions which belongs to the current month, resulting in faster execution and lower costs in BigQuery. Moving on to access control mechanisms in BigQuery, we can provide roles to individual users, groups, or service accounts. A service account is attached to applications or virtual machines to act on a user's behalf. The roles can be granted at various levels. If the role is granted at project level, it applies to all the BigQuery datasets in that project. A dataset is a logical grouping of tables in BigQuery. And so if the role is applied at the dataset level, it applies to all the participating tables involved in that dataset. And like that, it goes to table and the view level. These are already predefined roles. There are already predefined roles which fulfill most of the use cases like reading, writing, or the admin. But custom roles are also an option for more granularity. For further security, we can use authorized views, which lets you share query results with a particular users or groups without giving them access to the underlying tables. We can use the views SQL query to restrict the columns and the rows the users are able to query. So as a result of setting up this architecture, data started flowing from multiple sources to Google Cloud Storage. And this raw data was crunched by BigQuery, enabling in-place querying and analytics by creating business applications layers such as prediction and visualization. Most importantly, the customer was able to generate sales and inventory reports in an hour, down from 3 days previously. Since customer was now able to capture hourly data on key information such as delivery status, stock status, payments, etc., retailers and brand owners experienced high speed to market and sales turnovers on the customer's platform. The new data lake infrastructure has also proven to be successful during the early months of the pandemic lockdown, where customers saw a spike in food and hygiene categories and were able to meet this heightened user demand and provide brand owners with more sales opportunities during this time. So with this, we'll dive into a quick demo. So this is what we'll try to achieve, and I'll insert rows into a MySQL table, and via Debezium, it will be pushed to a Kafka topic, which will act as a broker. Then it will land to Google Cloud Storage via a sync connector. And once the data is available in Google Cloud Storage, we will create an external table in BigQuery and try to query that data in Google Cloud Storage. Let me present my full screen. I hope my full screen is available. So I have spin up a MySQL 5.7 database in Cloud SQL and having a private IP, and it has automated backups and point-in-time recovery enabled, which means the bin logs are enabled on this MySQL database, which will essentially tap into the bin log file to record the changes and the inserts and the updates. I'll be installing the Debezium and the Kafka on a single VM for this demo purpose. and a sync connector will be installed in this VM only. And this is the bucket where we'll push the data that will essentially land into MySQL. So this is currently empty. So let's start with, okay. Let me log into the MySQL through the client. Okay, we are into the MySQL database. I've already created a sample database for us to use. And I'll create a table, a sample table, which has essentially for 4 columns: the ID, first name, last name, and a phone number, and the primary key will be the ID. And we'll open another tab first. Okay, we are into a same VM. So this 8083 is basically a Kafka Connect web server, and it's the REST API for the Kafka Connect. So I'm basically just listing all the connectors that are available right now, and none of the connectors are available. So I'll create the connector for MySQL and the Google Cloud Storage. So going into the configuration of the MySQL connector. So this is the configuration I'll use to set up that MySQL connector, which will point to the Cloud SQL and read the bin log files and push the data to Kafka. So this is the name and the connector class, and I'm telling that you can have maximum 3 tasks to do this, and I'm giving the IP of the Kafka server, which is basically running on localhost. And this is the Kafka topic you can create for recording all the schema changes that are happening in the MySQL. So Debezium essentially tracks all the schema changes as well that are happening in the MySQL tables. And I'm giving the server name and the host name and all the configuration related to connection. And I'm whitelisting only one of the DB to track changes. So it will only track changes for this webinar DB and not any other. And there are some additional configurations to filter out the information that Debezium will throw to Kafka. So I don't want the schemas related to the rows. So that's why I put it false. And this is basically telling that I want my data in JSON. So, and another false for the schemas, and a lot of JSON converters for the key and the value. And here I am doing a transform. So Debezium essentially gives us a few transforms that we can do. It's very lightweight. So I'm just telling you can unwrap the row, unwrap your very nested JSON document, and just give me the new and the final row, the after one. I mean, if it's an insert, just give me the data that was inserted. If it's an update, then just give me the data that was the state of the row that was after the update. So we'll make a post call to the Kafka Connect REST API, telling that telling that here is my configuration, and you can register this connector with your Kafka Connect. Okay. Meanwhile, we'll check all the topics that are available in our Kafka server. So I was testing a lot of things. So this is essentially the topic that will be tracked. So the naming convention, Debezium automatically makes this Kafka topic. So this is the naming convention, which is the server name, the database name, and the table name. So we created this webinar test table here. So all the data from this webinar test table will essentially go into this Kafka topic. Coming to the GCS connector configuration. we have the connector class, the name of the connector, and format class is the JSON. We can have Avro here as well. And this flush size means that after you get 100 rows in your from your last offset, then you can commit and make a file in GCS. So this is a configuration that I'll be using for this demo, which is 100 rows. And we'll be using time-based partitioning, and I have given a format. So essentially, when the rows were landed in Kafka, it will go according to this partitions in the GCS. We'll see in some time now. Time zone is UTC and local is English. I think, yeah. So this is the bucket name that we'll be using for this demo, and this is the topics that I'm telling this GCS connector to track. So we'll be only tracking this topic, and essentially we are only tracking this only one table for this demo. This is the rotate interval, which is the 60,000 milliseconds. It means 1 minute. So either it will flush at 100 rows, or if the 100 rows are not completed, then it will make a file in every 1 minute with all the rows that it has got in the Kafka topic from the compared to the last flush. And this is the server IP for the Kafka server, and this is the storage class, and this is I'm giving the credentials to which service account to use to push those files into the GCS. And I have some other configurations related to serialization. And yes, I'm just telling that we will not be getting schema in your Kafka topic, so don't expect a field for schema. Similarly, I'll just register this connector with our Kafka topic as well. We'll just check the status of these connectors. If they are running fine, then we'll insert data into the MySQL tables. Okay, this MySQL is running fine. And 3 tasks are also running for the GCS sync connector. So essentially, we have the pipeline in place, and we can push some dummy data into our MySQL tables. So this is the dummy data that we'll be pushing into our MySQL tables. It is essentially 1,000 rows with dummy names and dummy last names and dummy phone numbers. So if I refresh this bucket, so looks like we have gotten some data. So this is the topic name that that the data corresponds to, the year, month, day, and this is the UTC hour. So yeah, it looks like we have got the rows that we pushed it to MySQL, and it has essentially created 10 files. Yeah, 10 files for, I mean, one file contains the 100 rows. Okay, let's look how it looks like. So yeah, it contains the 100 rows with the first 100 rows, and each file then contains the additional data. So we have gotten our data in GCS. Let's try to make an external table on top of it and then try to query it. So this is the console for BigQuery UI, and these are the options that are features available with BigQuery. And I'll just jump straight into creating a table in BigQuery. So we have all these options. We can query drive, and we can create an empty table, or we can load from Google Cloud Storage. That's what we'll do here. I have the URI ready. We'll just use a wildcard that you can scan all the necessary partitions to scan the data. We are just giving wildcard, so it will not miss any partitions when we query. But this is just pointing on top of that URI. Our data is in JSON format. Yes, we have partitioning. And I'll provide my own schema for the partitioning that is already present in the GCS. So this year, month, day, and hour is what we are seeing in the GCS. So we're just telling BigQuery that this is the partitioning in GCS. So I'm just create an external table. So if a new partition comes after an hour, I don't have to load it into BigQuery again. I'll just point it to the Google Cloud URI. For now, we'll just select the option for auto detect, so it will automatically scan the data and infer the schema from it. So we have successfully created a table on top of the Google Cloud Storage UI, and now you can see that these four columns are present in the data, but these four columns are actually the partitioning in the GCS. So we can apply where conditions in our query and have like where month equal to September or where month equal to August, and when it detects that there is a where condition on this column and it's a partition column, so it will go and scan only the necessary partitions in GCS corresponding to September or corresponding to the August and return the data. So, but for now we have only one partition, so and that doesn't make sense, but I'll just try to query these columns. So yeah, it goes to GCS and then scan the data, and then we can have reporting based on top of our data lake. So I am finished with my demo. I hope you liked it. I'll be going back to presenting the deck. Chandni, I like to bring back Chandni from Google for this slide. Yeah, thank you.
Thank you, Manan. Thank you for the demo and all the explanations. Yeah, totally agree. Fantastic demo.
Thank you.
Okay. So before talking about the partnership, I would also mention that while there are various GCP solution blogs, product tutorials, including next videos that I would really recommend all the cloud technologies to watch, partnerships are extremely valuable to scale. Now, to do that, we, Google Cloud Platform, are developing a range of industry-specific solutions with partners like Sears. And Sears helps futurify your business. So, Sears has been Google Cloud partner for over 10 years, and they're like now working 3,000 plus clients, which is like huge. And of course, they are a thought leader, whether it's infrastructure modernization that we had a session bit before, and now data engineering. Because of Sears' focus on customer outcomes and whether it's deep technical capabilities and executing at speed, they are a trusted go-to partner. In addition to that, I would also like to mention that Sears has been extremely critical to many of the customers, even involving stages where there are like cost-saving conversations or optimization. So definitely we look forward to continuing this growth and this partnership. Thank you.
Great. Thank you so much, Chandni, and thank you, Manan, as well. That was quite the fruitful overview on data modernization. As far as all of our attendees, I would like to thank you all as well for joining today's webinar. In regards to next steps, we will be sending the recording as well as the deck that was presented. We also would like to recommend that you visit Circe's Medium blog, where we have written about a myriad of engineering topics. Finally, if you are interested in receiving a tailored workshop to address your cloud needs, please email us at the email address below. And Samya has also posted this email in the chat window.